In these two multiple choice questions, we're going to have a look at a more difficult side of thermal physics. To start with, it gives us the mass of an air molecule. It's asking us to find the mean square speed after giving us the temperature in Kelvin. So we don't need to convert it into Kelvin, which you do have to be careful of because a lot of time it gives you in degrees and you have to convert into Kelvin. Just a reminder, by the way, you add 273 to degrees to get into Kelvin format. So what we use here is the equation for average kinetic energy. We know that the average kinetic energy is a half times mass times root mean square speed squared. And we also know that it's equal to 3/2 times Boltzmann constant, which is given to you in an exam, multiplied by temperature in Kelvin. Because we know the mass and we know the temperature, we also know Boltzmann constant, we can just rearrange this equation to make mean square speed the subject of the formula. So how I'd recommend you do it is first multiply both sides by 2 to get rid of the half there, and then you're left with m times mean square speed is equal to just 3 kT, and then divide both sides by mass. So let's now focus on doing this calculation. So 3 multiplied by Boltzmann constant, which is 1.38 times 10 to the power of minus 23, multiplied by the temperature in Kelvin, which is 750, all divided by the mass, which is given as 4.8 times 10 to the minus 26. If you type all that into a calculator, it will give you option C. Perfect. Let's move on to the other multiple choice question, which is also quite difficult. It tells you a stream of water falls through that distance. It says assume no thermal energy is transferred to the surroundings. That's important. It's also told you the specific heat capacity, and it's asked for the temperature difference between the top and bottom. So this is focused on energy conservation, and it uses the idea that as the stream of water falls a distance of 100 meters, it's losing gravitational potential energy, and all of that gravitational potential energy is being converted into energy used to heat up the water. Now, in reality, some energy is going to be lost to the surroundings because of work done against air resistance or something like that, but it specifically says assume no energy is lost to the surroundings. So gravitational potential energy is mass times g times change in height, and that's equal to energy used to heat up the water, which is the energy related to specific heat capacity. That's mass times specific heat capacity times change in temperature. We want to find this temperature difference. Straight off the bat, we can cancel out the masses from both sides, and we get that the temperature difference is g multiplied by change in height, which is the distance that it falls, all divided by specific heat capacity. So that's 9.8 multiplied by the change in height of 100, all divided by the specific heat capacity 4200, and that gives you a value of 0.23 Kelvin, which is option B. If you have any questions with that, just let me know in the comments. Otherwise, please like the video if it helped. Hopefully it'll get out to more people. Be sure to subscribe too. I'll post more Year 2 content from now on.